Here we're going to show how we can simplify when we multiply rational expressions. So the first thing I'm going to do is I'm going to look for where I can factor. And I think this numerator here is a factorable problem. There are two different ways that we could go about it. I'm going to show what I think is the more complicated way by grouping. And then we'll look at how we could have done this a different way as well. So 2x squared minus 10x plus 12. When we are factoring by grouping, we look at A and C first. So 2 times 12, that gets me 24. And now I need to find a pair of numbers that multiplies to 24, but that adds to negative 10. I know that if I multiply two positives, I get a positive, but if I added them together, I would never get a negative. I could also multiply two negatives and get a positive 24. And when you add two negatives, you will get a negative answer. So I'm going to be using negatives for both the first and second term here. So negative 1 times negative 24 gets you 24, but they add to negative 25. Negative 2 and negative 12 multiply to 24, but add to negative 14. Negative 3 and negative 8 get me negative 11. Negative 4 and negative 6 get me the negative 10. So these are the two numbers that I'm going to use to replace or substitute in for negative 10. So I rewrite my problem, 2x squared minus 4x minus 6x plus 12. So remember, when we are grouping, we leave the first and the last terms, but we just rewrite or we break up that middle term so that we have now 4 terms and can make 2 small groups. Negative 4 and negative 6x is the same thing as 10x. We haven't changed the value or anything, but now we can make 2 equal groups. So now I'm going to look at 2x squared minus 4x. The greatest common factor that they have is 2x. 2x times x is 2x squared. 2x times 2 is 4x. For the second piece, if I do the same thing, I want to know that I'm going to end up with the same value inside the parentheses. So I know it needs to be x minus 2. What times x is negative 6x? Oh, that's negative 6. Negative 6 times x is negative 6x. Negative 6 times negative 2 is a positive 12. So this is its factored form. But there is one more thing that we can do. 2x and 6 both have a common factor of 2. So I can factor out a little farther. 2 times x plus 3, or x minus 3, sorry, is the same thing as 2x minus 6. So now I have that first numerator fully factored. The denominator there, x squared minus 4, that's a difference of 2 squares. That's an x minus 2, x plus 2. Remember, we always want to have our eyes open for those differences of 2 squares. The second fraction here, 2 plus x and 3 minus x, there's nothing there that I can play around with or factor. Remember, we treat them like they have parentheses around them. And now I look for pieces that match up. All right, 2 plus x is the same thing as x plus 2. X minus 2 is the same thing as x minus 2. Now, if I look at x minus 3 and 3 minus x, I want to think to myself, is there a way to make them look the same? If I factor out a negative 1, it would switch their signs. Negative 1 times negative 3 is a positive 3. Negative 1 times positive x is minus x. Another way of writing this is negative 1, x minus 3. Well, if I do all of that, I now see that I am able to divide through by x minus 3. The only values that are finally left are 2 in my numerator and negative 1 in the denominator. And if I simplify 2 and over negative 1, I get the answer of negative 2. This one actually comes out to be an integer answer. As I said at the beginning of the video, there is another way we could have done this that might have saved us a little bit of time. So I'm going to show you how to do that next. I'm going to erase everything on the board. And I want to start by thinking about how I could factor that numerator. When I look at the numerator in the first problem, I see that there are 2's already there. So all of these have a factor of 2. So I can factor that out at the very beginning and get 2 times x squared minus 5x plus 6. And the only value that this has here is that it makes it so that I don't have to do the extra work with factoring by grouping of breaking up that middle term, because now I have a equals 1. So if I did it this way, I'd be looking for a pair of numbers that multiplies to 6, but adds to negative 5. So multiplies to 6, but adds to negative 5. Just like with the 24, I know when I need 2 negatives, negative 1 times negative 6, multiply to negative 6, but it gets me negative 7. Negative 2 times negative 3, multiply to 6, but they add to negative 5. So I could have jumped to this factored form there. And that would ultimately get me to the same place that I was in the original problem we did. I just wanted to show that we could have done that factoring a little bit easier, a little bit different at the very beginning, but we would get to the same answer.